So welcome to another edition of Siemens Community Conversations for our Technomatics virtual user group. My name is Kelly Gallagher, and I'm the Digital Marketing Manager supporting the Siemens Technomatics portfolio, including plant simulation. Today, we're joined by Stefan Bangsau, who is going to demonstrate overall equipment availability and efficiency in plant simulation. Stefan is a freelance simulation expert with his work beginning in 1999. Many of you are familiar with him, and he's published several books on plant simulation, completing hundreds of trainings, and is one of our leading contributors to the Siemens community site. For our agenda today, Stefan will walk through how to define definitions and modeling approaches, how using buffers influences overall equipment availability and efficiency, and then lastly, discuss modeling performance. Stefan will be demonstrating these capabilities, and we'll have a live Q&A. You can either use the chat to prompt your questions, or you can use the hand raise feature on Teams, and we will take you off mute to ask your question. And with that, Stefan, I will hand it to you. Thank you.
Thank you, and hello again to our next session. Today, I want to show how we can include the OEE in our simulation models. And you see here one of the definitions for OEE. It's availability, performance, and quality. And we start with, a very simple use case. I want to have a line consists of 3 stations. Each station has a cycle time of processing time of 1 minute. And we need to set our event controller here. I want to have statistics reset at 1 hour. And the total simulation time of 100 days and 1 hour. To calculate the maximum output. And this is the first step. In this case, it's very, very simple. We can produce in each hour 144 parts and 1000 in 1 hour we have 60 parts, and this in 1 day it's 1440 parts, and so we get for 100 days 140,000 parts. I check this. And this is our one base number we need to calculate the OEE later. So we have our 140,000 parts and 1,440 per day. And if you have a more complex model, then you need this performance measurement here as max throughput, for instance. And this we need to calculate later our OEE figure. So I create a global variable here for the maximum throughput. and I set it to 1,440,000. In more complex models, you need to create a simulation one without any influences, with 100%, with no failure parts, with 100% availability, and without any losses through performance, through bad performance. And so you need to calculate the max throughput during a certain amount of time. So in the first step, I want to include the availability, and I just copy here the complete line. And this is quite easy. I want to have for each station 95% availability with 5 minutes main time to repair. So I activate here the failure, 95% availability and 5 minutes MTDR. And this in all stations. You can calculate the overall equipment efficiency, which means, okay, what is the efficiency of the complete line here? If you don't have buffers in between, you can calculate this in a simple way. Okay, and you can calculate this just by multiply all the probabilities together, and it's 0.95. And you get an overall equipment availability of 0.8573. This is the theoretical value. Okay, let's have a look in our simulation. What we need to calculate here is the output after 100 days here, and we need to set this in relation to our maximum throughput. And so we need one method, one NSIM method. And another variable here. I name it overall equipment availability. And this is my terrain 1. Stadnum out or Stadnum in, you can take here if you want to have it in percentage, you can multiply it by 100. And this is our first step here. And if we now run the simulation for 100 days, okay, it's not the right format here. Needs to be real. This is one of our big problem in plant simulation. You will need a lot of failure events to get exactly to the availability that you set here in the stations. If you go now in the stations here and have a look into the statistics, then you will see, okay, this is until now only failed for 4.97%, not for 5%. And in the other stations, it's also not exactly 5%. If you look here in the statistics, it's 4.92% and so on. And so you need a very long simulation time to get here this value exactly how it would be if you calculate it here in Excel or with the calculator. It needs more simulation time to get a better result here, or you take the experiment manager. The experiment manager, and I want to have the OE or line, and you run several observations, maybe 5. And then you get the simulation runs with different random values, and by calculate the average value of this key figure, you get a better result. And I just try it out. You don't need to define any input values here. Okay, and now it's 8572. And this is a better result than only the one simulation run here. And so we are much it's more in the area of this theoretical value. Another way would be to increase the simulation time. but then we need to calculate the max throughput here. And so you get also a better, so you get more random events and better representation of this key value. If you have too short simulation times, then you get a complete different value, and then it's a clear sign that you need to increase your simulation time. So you need to be careful here. If you place buffers in between, placing buffers in between is one of the main actions you can do to increase the overall equipment availability. Because if one station is in failure, then the other station can work until the buffer is filled. And if the station before is failed and you have still some parts in your buffer, the next station can produce, and so you can reduce the impact of failures in a complete line. So I copy this all together. And I place some buffers in between. Okay, I create another overall equipment availability variable here with underline P for underline B for buffer. And this is now train 2. And I need to extend my nsim method. I want to calculate this value now. And it's almost the same like this. We need still the calculation of the maximum possible output here. And we set this only in relation to this key figure here. Let's do a simulation run. Okay. Now my availability is increasing from 85% to more than 91%. And one of our frequently asked questions in the simulation is what's the optimal dimension of these buffers, because buffer, it needs place and it costs money. And so the optimization of these buffer sizes is one of the main questions in many simulation studies. And here you can use, again, the experiment manager if you have only some buffers. If you have more buffers, then it becomes quite difficult to find a solution with the experiment manager only. And then you can use the genetic algorithm to find an optimum OEE, for instance, or throughput. by optimizing, by changing the quantity of these buffers step by step. And this would be one additional webinar. Okay, so by placing buffers in a line, you can increase the overall equipment availability. You can see here, but this is only the first part of the OEE. The next part is performance, and this is quite difficult because each company defines performance loss different. I know companies where the brakes of the worker is already performance loss, and many define performance as all influences that causes some delays in the cycle time, in the shortest cycle time. Our shortest cycle time is here 60 seconds, and all influences that causes one delay in this 60 seconds is already performance loss. And we have three big groups of performance losses. One group is performance loss caused by the worker. For instance, that he cannot be available 100% of his time, or he has changed efficiency during the daytimes. Another group is performance losses caused by material, that the logistics is not able to support the stations with material each time at the right time, and so the station is waiting because of missing material. And then you have performance losses because of the process itself. For instance, if you have a rework on a machine and you don't have additional machines for a rework and need to do the rework in the process itself, and then it causes a longer processing time on a certain machine, and this is also a performance loss, and is one point that goes into our OEE key figure. I want to make loss through the worker, and so okay, very important is you need to measure this performance without the influence of the availability. And so I take here this line, and I deactivate all failures here. And then I need workplaces for the worker here. I activate the processing importer. I need a worker pool. In the worker pool, I need to have 3 workers. And I need a broker. And I need again one global variable for performance. If you have one big model, you can make the availability. You can switch on, switch off the availability by set. You can activate it in the same way. Here it's available with for SimTorque. It's a failure active, and so you can make a list with all the stations and set the failure active attribute to true or false, so you can switch off and switch on the failures quite easily. If you want to have all these 3 elements separated here for the OEE calculation. Okay, in our NSIM, I want to calculate the performance key figure here. So, okay, I rename this train here as train 3. Okay. And then I can take this one. Performance. What does it mean if you have only a 98% availability for the workers and we have some buffers in between? The buffers works in the same way like for the availability. If one worker is on at the washroom and there are still some parts available in front of the other machine, then it can run until the buffer is empty. Another way to increase the performance then would be to work with floaters. Then another worker comes when one worker needs to go to a break or want to smoke a cigarette and so on. Okay, let's have a look. Oh, performance is 100 because I forgot to set the availability of the workers. I need to do this in the class library. Resources, this is the worker I create. I hope this is the worker I create. It's the basic from resources, basic worker from resources. And here you can find, that's the worker pool. That's the worker, and you have failures here also, and you can create a new failure profile, 98%. And maybe it takes 10 minutes. Okay. One more try. So now we get a performance of 97%. We can make it in the same way that you make several runs with the experiment manager, and the experiment manager calculates the average value, and then you get a better value here. But we don't have so much time today. So this is the second part, and it's maybe very difficult to get the data for modeling this, and something are happening in the simulation if you have not enough transport work or transport capacity, for instance, then you get a performance loss through the distribution of the material, and all the other stuff you need to find. You need to find some data if you want to do this, and you need to have a closer look into the definition of performance in the company you make the simulation for. There's a lot of different definitions out there. The third element here is quality, and quality means it's just the calculation how many of the possible parts comes to the train, and so we need to include here some quality losses, some scrap into this calculation. And here again, the buffers don't have influence on this, and so I need this basic model from the start to calculate this. And we need to be sure that we don't have failures active, that we don't have any influence to performance losses. So you need to create this based on a quite generic model. I want to calculate a loss of 5% in a station 2 and 3. Okay, we have already in this, it's station 12 and station 22. Okay, very important is that you select that you add a new train here for this, because you need to separate the scrap and the NOK parts from the OK parts, that you can count the parts here in the last train. And so I need one more train. And a material flow to this train as a second successor. And the easiest way to model scrap and not OK parts is the exit behavior of the stations. You can here select the station behavior random, click OK, and then you get a list. And then you can define a probability for selecting the successor 1 and successor 2, and this is 95% and 5%. And the same here in the last station. Random exit behavior, 95% to successor 1 and 5% to successor number 2. Okay, and then I need to calculate the number of parts in this drain 4 in relation to the maximum number of parts. And this is the P figure for quality. And so I need the next variable for quality as real. And I need to extend my enzyme method. Almost the same. Quality. This is train 4. Okay. I make a simulation run. And you can see, okay, it's not 10%, it's less than 10%, and at loss the loss is only 9.7%, because you have less parts here at the last station, and so 5% of less parts are less than 5% of 100%. It's less, and so this is the quality. And now we have all 3 parts that we can use to calculate the OEE. I can take these 3 variables to calculate this theoretically. So I make another variable for OEE calc. As real. And I need to multiply this OEE B and performance and quality, like in the equation at the start here. And if you don't trust here your calculation, you can set some brackets around. Okay, I just start the enzyme method again, and we get here OEE of 80%. But you don't need to make this steps step by step. We can calculate it directly from our simulation model, but I need to start with a base here. I take this as a base. And I activate the failures in each station. Okay. Then I need a second train. For the quality losses here. And I need to set a new exit, random behavior 95.5%. I need 6 workers now. And then I have all the influences together in my last model here, and this is train 5. And then I can make my final OEE. Okay, if you have all this together, you only need from the very start the calculation of the maximum possible throughput, and then set it in relation to the output of your OK parts train. It should be train 5. Okay, no. Okay, it's train 31. Okay, and I need to start. Okay, it runs now with different random numbers, and so it's a slightly different number here. It's almost here it's 80%, and here it's also 80%. And so this is the direct way. You need to calculate once with a simulation run without any disturbances here. Or you can calculate it, the maximum throughput during a certain time, include all the elements, and then you have the OEE directly. If you need to have all the elements of the OEE separated, then you need to switch off the availability, and you need to switch off the worker influences and performance influences, and you need to switch off the scrap to have this tree in a separate way, like I done this now. Okay, that's it. It's not an easy task if you need to get all the information, and from a certain point you cannot calculate it with mathematics alone. For instance, if you place buffers in between, then it's the overall equipment availability is slightly different from the calculated theoretical value. And the same is for performance. If you have, for instance, this kind of performance losses, then also the buffers have influence on the real number. And so it's very hard to calculate it theoretically. And we can provide here one approach to make this using simulations. Okay. Any questions? Is increasing the worker speed and increasing the worker efficiency the same thing conceptually? Depends, no? It depends on if this has influence on the total throughput, because our final measurement is total throughput, and if the worker is working with a higher speed and it doesn't have any influence, then you cannot do this. But normally for really increasing the OEE by eliminating all the worker influence is really floater. That you have some people in your production that can replace temporarily some worker that is not available. This is one of the basic concepts to increase the performance. But you need to test this in your model. We can test this really easily.
Thanks, Stefan. And while those are thinking of other questions, I will share a slide. Just as a reminder, so for those that are not following the plant simulation community, you can navigate to the virtual user group on our community site. And on the right-hand side, there's a widget that says following. So once you select that, you choose to subscribe to every post. So that way you receive notifications of the virtual user group sessions like this that have been published. So you can watch them on demand, or you'll receive notifications when to register for upcoming sessions. So please note our next session will be Wednesday, July 23rd, where we'll be discussing marker reservations for free moving AGVs, and that will be hosted by Alex Dilg, another one of our plant simulation experts. And then Stefan will join us on Wednesday, August 6th to discuss deep dive exit strategies of material flow elements. And with that, we'll go back to the audience. If there are any questions, please feel free to put them in the chat, or we can also unmute and discuss.
Yes, there's another remark here, maybe not a question, but rather an observation. OEE calc differs from OEE not only to random numbers, but also because in the last line, availability, performance, and quality factors interfere with each other. Yes, this is a simulation model. It's dynamic, but it's difficult. Here, the elements have different starting points in the random streams, and so they run with different random numbers. And you can easily compare this by, okay, it's difficult to have a base here, but I have here availability. Okay, and this one, for instance, this station at the end statistics was 4.83% failed, and this station statistics is 4.91%, because internally this element has a different starting point in the random stream, and so it has a slightly different behavior. It's not a complete copy of this one. Yes, but if you have a normal, it's only for this example. If you have only one instance, then you don't have these problems that you have. And it's different, not a big. Okay, again, in the user community, you need to click on Technomatics. You'll find the Plant Simulation Virtual User Group under Technomatics. click on follow if you want to have all information. This is not a regular part of the community. Here we only post things that are related to our virtual user group. And you can find all the recordings here in new knowledge articles. And here's one article on demand video. And here you can find all the recordings. Yes.
Okay, great. Well, thank you, Stefan. And if
Thank
there
you.
are no more questions, we will conclude today's session. And as mentioned, it will be available on demand, published here. And Stefan, thank you for the time today, and thank you to everyone who joined. We look forward to having you on our next virtual user group. Thank you.
Goodbye.